All right, this is lesson one, the concept of a function. How do you identify people using fingerprints? Everyone has unique fingerprints. In other words, there is one-to-one relationship between a person and his or her fingerprints. In mathematics, this type of relationship is called a function. In this chapter, you will learn how to identify mathematical functions and also how to represent them using tables, equations, and graphs. So the first thing that we're going to talk about is domain and range. So for example, on this left-hand side, we will have a domain. On the right-hand side, we will have a range. Okay. On this side for a domain, if we have names like Diane, Linda, Mark, John, and Jacob, we have a range of Kathy, Kyle, Kelsey, Lucy, and Gary. A domain is called the input, and our set is Diane, Linda, Mark, John, and Jacob. Our range is the output. And that set would consist of Kathy, Kyle, Kelsey, Lucy, and Gary. So for each of these, if the input goes to each output, we would call this a function. One input to one output, which is very important. So again, we're going to star this and say each input has one, and I'm going to underline this, output, which is very important. And again, we're saying this down here. A function is a type of relation that assigns exactly one output to each input. So functions are common in everyday life. So next, let's do some examples of this. So for example, which of the following are functions? Well, for a keyboard, if I were to type on a keyboard the letters A, B, and Z to type, okay, on the screen, you would have A, B, and Z. So you would have A to A, B to B, and Z to Z. So the answer is yes. So that would be a function. Next, shopping. I'm going to move this. It's my eraser, guys. Shopping, okay? If we have some products on our left-hand side, products, and we have a bowl, and we have a glass, and we have a plate. And the prices of those cost were $2 each. Each input has only one output. Though it's the same price, each input has exactly one output. That is a function, so that is yes. Next, football. Well, here again, we have players, Allen, Mahomes, Kelsey, and positions. Quarterback, tight end, Allen, Mahomes, Kelsey. Again, this would be function. Each input has exactly one output. The Dewey Decimal System. Now, I know a lot of you guys don't know what that is, okay? But a Dewey Decimal System consists of different categories. So here we have a category. We have one category here, which is 400 and 500. We have another category, and I'm going to write it first because it's long. So let me restart this here. In our other category, so 400 would go to English dictionary and German dictionary. 500 goes to probability and zoology. Here is not a function. The answer is no, because we have one input going to two outputs. Therefore, not a function. So now it says, can you come up with a real world example of a function and not a function? Well, one example of a function, okay, test scores. of 5 students. Each input has one output. I have truck and a car. They have 16-inch rims and 18-inch rims. Car has 16-inch rims. Truck has both 16-inch rims and 18-inch rims. Not a function. One input to 2 output values. Okay. All right. So next. I know the lights just went off, guys, and I'll fix that in a minute. Actually, I wouldn't mind leaving that. We don't have a glare. I'm going to leave that, guys. We don't have glare. Okay. Next. Well, I better actually turn it on or else cleaning lady will be in. Okay, so 2 different table of values are shown below. Make conjecture about the differences between the 2 tables. What do you notice? Okay. What I notice is the one on the left, okay, we have one value for each input and one value for each of the output, 1 to 1. Here I have 2 output values, or sorry, I have 2 input values. I have 1 input value, sorry, going to 2 output values. Oh my God, sorry guys, it's the end of Friday. So sorry about that, guys. All right, so now using the table, and I'm going to show this table as much as I can until I get down to the lower part of this. All right, so using the table on the left, state the distance the stone traveled in 1 second. So in 1 second, that stone traveled 16 feet. Using the table on the right, state the distance the stone traveled in 1 second. That's a little bit harder because it not only traveled 4 feet, it traveled 36 feet. So now it says, which of the 2 tables above allows us to make predictions with some accuracy, and explain? Well, the table on the left because the one on the right gives 2 distances. for 1 second. So it could be one or the other. That's all that really needs to be stated. It could be one or the other. Using our definition of a function, in other words, a type of relation that assigns exactly one output for each input, determine if each table is a function and explain. The table on the left is a function. Because it has one input to one output. The table on the right is not a function because there are two output values of 4 feet and 36 feet for one input value of 1 second. Okay? Next. Let's connect this idea to the mapping diagram from the previous lesson. So from the left table, we have point 5, 1, and 1.5. And they go to 4, 16, and 36. So they are 1 to 1. On the right table, we have 0.5, 1, and 2. And they go to 4 and 6 here. So we go 5 goes to 4, 1 goes to 4, and 1 goes to 36. Both 1 and 36. So now we can also, we can also determine if a relation is a function using ordered pairs and graphs. Using an ordered pair, we can look at this. Each input has exactly one output, so therefore function. For our explanation, each input has one output. This one we have here, not a function. The input of 6 has two outputs. Of -8 and -5. Next, looking at a graph, if we look at a graph, this is a function. Again, each input has one output. Looking at our next graph, it is not a function. Right here, we have an input of 6 has two outputs. Of 4 and 6. The next thing is the vertical line test. This states that if a vertical line on the graph in other words, use your pencil, crosses only once, it is a function. So for example, let's go back up to these. Notice this line. If I use my pencil and I can move it across the graph and it only crosses once, it is a function. However, moving it along this graph, and I move it along this graph, notice right at this point, it crosses twice, therefore not a function. So here, if I can use any representation and I can create an example of a function and a non-function, if I want to use a graph, I can simply draw any graph I want as long as it is and it passes that vertical line test. If I were to use points, just remember one input for one output. For not a function, if I want to use for a graph, I could use something that would be similar to something in maybe like this. Because if I were to draw my pencil, oh, let me move it this way. There you go. If I were to put my pencil here and move it across, it's going to cross, and not only here, but here at the same time. Okay? And therefore, it would be not a function. If I were to use a set, two input values would have, or one input value would have two output values, therefore not a function. And that ends today's lesson.